Hello, this is a brief video I would like to do to explain how I'm going to create regression models. So what I want to do is to predict actual cost based on 9 independent variables. These variables are material cost, engineering cost, logistics, finance risks, services, overheads, installations, and others. So I created a hypothetical datasheet containing 35 project data and the material budget, engineering budget, logistics, finance, risk, and the other 9 variables. And these are the total budget. And I just made a hypothetical actual budget. So I'm going to use RStudio. And the first thing I need to do in RStudio is to scale the data. So instead of having like 10 million project for 35 projects to vary between like 1 million to 5 million or 10 millions. So I will scale everything to be from 0 to 1. That make it easier for the regression model to update the algorithm. So first step, I make data pre-processing. So I create a function called scale 01, and the function, it's a function receives read value, and what it does, it just scaling the information. So it shifts the data by the minimum and then divided by the range. Maximum of x minus minimum of x. So this is the information, and I already imported the data, and I call it project data. So I'm going to create a project data scaled, and it's a scale 01 of project data. So let's view the project data scaled. Here we have, and I transfer that into Excel sheet. So the Excel sheet contains independent variables and the actual costs. All are scaled from 0 to 1. Okay, so second step is to divide the information into two parts. So I set seed this 5, it's random to randomize data, and I created a project data train. It's like sample underscore frac. We accept the table equal project data scaled. Now replace equal to false, and size is 108. I already did that, and that will go an error because I didn't call the library for sample fraction. Anyway, I already did that before. Project data train. We can view it here. Okay, view project data train. Here we go, and I transfer that to the train dataset and this dataset. So these are the information I'm going to use for my regression models. So I split into train and testing data. Okay, so now I will start by artificial neural network regression model. So let's make a set seed for randomize 1, 2, 3. These are just numbers, and I create a model. I call it model ANN1, and I use neural net. It's a function. All I do is just give the data, the actual score cost. This is the dependent variables, and the independent variables are all other variables in the data, and data equal project data tree. So here the actual data, actual cost will be the dependent variables, and all others will be independent variables. So okay, actual, yeah, I missed. I spelled typo here. Okay, and then what I need to do that I plot the model. So and then one, and here we go. This are the model I'm going to use, and it's showing error here. Okay, so what I need to do again is to calculate the data. Or before calculating the data, I need to put here the predicted value. So I'm going to show the result of view model underscore in1, the net dot result. That will, okay, no need to use view. Here we go. These are the data, so I copied them into that Excel sheet here. Okay, so what I need to do again is to calculate sum of square error. So it's easy. I can model for NN1 score train sum square error and just sum of all errors, and model underscore NN dash NN1, yes, sorry, this dollar net dot result and minus project data train, sorry, actual cost, and I need to sum them all square and then sum. Yeah, here we receive an error because it's the model result, the it's like a list, and I need to unlist this result. And yeah, what what I miss, I think there's some missed some, this one parenthesis, the second parenthesis, okay, and square, I'm not sure what it does. Yeah, okay, so let's check on, yeah, here we go. And I did the same using the data for Excel sheet and showing the same value. So second thing, I can do the same for um, test it. But before I do the test set, I need to make a prediction for the test first. So what I need to do, model in N1 underscore test. So this will be the information I will compute the output using the model I created. Okay, and using the project data set variables, the 9 columns, all variables 9 column, and I get net. Okay, net result. Okay, you can check now model in underscore test. Okay, this I copied them into the Excel sheet here. So I calculated the sum square error, and I need to calculate the root mean square error. There is a function I can use here. It's easy to use and easy to calculate. So let me calculate model in n1 underscore the train root mean square error. Okay, it's root mean square error. It's a function called root mean square error. What I give, it's two matrices, so they will calculate. It will calculate the root mean square variable error between them. Let's first the data, the actual data. Okay, and the model result, model underscore nn1 net dot result, showing the same error. I need to unlist. Okay, okay, let's see nn1 underscore train. Okay, here we go. So it's matched with value. So what I'm going to do, I'm going to repeat for all regression models, and I'm going to use these variables to compare the efficiency of the models. This is the first video, and I will follow with other video. It will be more quick to explain the other regression models.